Hi there guys, and welcome to Keeping It Simple. With this video we'll be looking at the global air circulation. I've tried to make it as simple as possible. Now to understand the global air circulation, which is just theory, I wanted to give you some type of scenario where you can try and imagine the reason why we're talking about the global air circulation. If you've ever looked outside before and was curious about the weather, then you would like geography more than the average person. Now, you're just looking outside and you'll be seeing the nice warm sunshine, you'll be feeling the cool breeze, you'll be experiencing the nice summer days, and more often than not, this type of weather makes you feel that you're in paradise. Nature has a very funny way of making you feel both comfortable and also very uncomfortable at the same time. What I'm talking about is the fact that with the good weather, you also get the air quotes bad weather. Now this way I'm talking about rainstorms, windstorms, hurricanes, tropical storms and thunderstorms, which may look unexpected at times, but it only looks unexpected to the untrained eye. One of the main ways in which we can begin to understand these mood swings of nature is through understanding the global air circulation model. It sounds very complicated, but once you hear the explanation, you watch the video, you get to see how easy this phenomenon or model actually is. Now let us go to the equator. The equator receives direct sunlight because of the tilt of the earth. Due to the direct sunlight, the equator becomes the hottest part of the earth, immediately turning earth into a low pressure cell at the equator. It is this tilt of the earth together with the spinning that creates the Coriolis force, also known as the Coriolis effect, which bends the movement of air in the northern hemisphere and the southern hemisphere, which creates the trade winds in both hemispheres. After the heating of this air at the equator starts the air circulation that we know Earth to have. It has also been said that planets such as Mars and Jupiter share a similar air circulation model than that of Earth. Let us go directly into the three main cells that are responsible for the air circulation on Earth, which are Hadley cell, the Ferrel cell, and the polar cells. Let us go first directly to the Hadley cell, which is at the equator. So the Hadley cell, located at the equator, is associated with predominantly warm air. The Hadley cell is responsible for the energy of the air circulation. At the cell, warm air rises at the equator, which is at 0 degrees, and sinks at 30 degrees, creating a high pressure system or a high pressure zone. This high pressure zone is also known as the subtropical high. Once the air rises and moves along the tropopause and sinks at 30 degrees north and south of the equator, the air then sinks, splits in two parts. One part travels to the poles and the other part travels back to the equator. This happens both when air sinks and air rises. That takes us to the next cell, which is interleading directly into the Ferrel cell. Air from the subtropical high zone flows from the polar region and meets the air flowing from the equator or the equatorial zone, which is the Hadley cell. Once both these fairly cold air meet each other, their natural nature is for them to rise, and they are rising at 60 degrees north and south of the equator, creating a low pressure zone. The air then moves along and sinks again at the poles, which is located at 60 degrees to 90 degrees north and south. Once the air sinks at 90 degrees, it flows along the surface until it meets air from the subtropical high and rises to complete the polar cell. There are prevailing winds that occur within both these hemispheres, because of the Coriolis effect and because of the sinking and rising air. But it's a bit too complicated to be put into a short video like this, so look out for our next video on prevailing winds. Thank you for watching our video. Please make sure to like and subscribe.